This discussion is the second part of our look at Chapter 6 of our Human Anatomy and Physiology text on bones and bone tissues. In Part 1, we looked at the structure of bone, different types of bone tissue, what it's comprised of, and now we're going to take a look at development of bone. This is a little bit of a departure because, as we said in the beginning of the semester, we are not going to really entertain much about development, embryonic fetal or fetal development in this course, but in this case, we'll take a few minutes to look at how a couple of different types of bones form, a couple of different processes by which bones form, I should say. So ossification is the process of forming bone tissue. It starts early in development and continues all the way through early adulthood. We still see some changes taking place in the skeleton as late as in the 20s or late 20s. In addition, we will also mention that the skeleton is constantly remodeled and renewed by osteocytes throughout life. So in order to maintain the resilience of bone, it's necessary to keep regenerating, replacing it, refreshing it. So, all right. Two developmental processes we're going to look at right now. One is called endochondral ossification. And you see that familiar root word chondro in there, meaning of cartilage, and endo means within. And so ossification is formation of bone within hyaline cartilage. Well, it turns out that during embryonic development, large parts of the skeleton form initially of hyaline cartilage, so they're called models. They look exactly like the bones will ultimately look, but it's just made of hyaline cartilage instead of bone. And then within the hyaline cartilage models, bone tissue is going to form by a process we'll take a look at. Intramembranous ossification occurs as connective tissue membranes, essentially equivalent to like probably dense irregular connective tissue, forms in the shape of certain bones, and then that becomes converted over to bone tissue, and that's called intramembranous ossification. So let's start out with endochondral ossification, and as I said, much of the skeleton exists initially as hyaline cartilage models. So the blue right here represents hyaline cartilage, and it's a model of a bone that is now going to become ossified. And the first step of endochondral ossification involves formation of a bone collar around this model, around the diaphysis of this model. So some cells arise here that are going to be able to secrete some bone matrix and so forth, and is essentially going to starve the cells in the interior, because as you may remember, hyaline cartilage has no blood vessels of its own. So what happens is the interior of the tissue begins to deteriorate, and it begins to calcify. Calcium phosphate crystals begin to form and precipitate here in this inner part. It gets kind of crunchy and calcified in there. As the process continues, it actually forms a hollow medullary cavity, and a whole raft of embryonic primordial cells invades that hollow interior there. It's called the periosteal bud. It's kind of a wonderful magical thing that happens, in which some progenitor cells that can give rise to blood vessels and nerves and bone tissue all just pierce right through and enter into that inner part and start to produce some good quality bone tissue in there. So that's the invasion of the periosteal bud and formation of spongy bone. As time goes on, the walls of this forming diaphysis are converted to compact bone. That's that lamellar bone with a long stick-like cylinders that form a very strong wall of this bone. The medullary cavity continues to form, opening up from what was spongy bone. Blood vessels are growing in. And in addition, the periosteal bud invades the diaphyses, the heads of the bone, and start to ossify those areas in a way similar to what happened initially in the diaphysis. Those are called secondary ossification centers. And as the bone continues to form and reaches the completion of the process, the ossification of the epiphyses continues. Compact bone forms on the surface. Hyaline cartilage, articular cartilage will be retained. the last remnants of the cartilage model will be retained where the joints are going to form, and there will also be a remnant of hyaline cartilage remaining between the epiphyses and the diaphysis of this bone. Those are called the epiphyseal growth plates, and it turns out that dynamic activity in that cartilage growth plate is what allows the bone then to grow longer during the course of childhood development, and especially during adolescent development. So that's the process of endochondral ossification, starting with a hyaline cartilage model and winding up with a full-fledged bone, fully ossified bone with a medullary cavity. Okay, formation of flat bones, not the only way flat bones can form, but this particular developmental process is called intramembranous ossification. In this case, instead of starting out with a hyaline cartilage model, we start out with a model made of fibrous connective tissue, probably equivalent to dense irregular connective tissue proper, but it's not called that because it's called mesenchymal tissue. In the embryo and in the fetus, everything has its own terms. Developmental biology is a very rich and science with a lot of history and a lot of contributions over many generations, and so the terminology is very well entrenched. So anyway, mesenchymal cells, fibroblasts, are going to form some fibrous connective tissue models of some parts of the skeleton. And the conversion of that connective tissue proper, effectively, mesenchymal tissue over to bone is called intramembranous ossification. So these are some of the bones that will form by this process. So this thready-looking, fibrous-looking material is representing the fibrous connective tissue, the mesenchymal tissue, and the purple cells, which are essentially baby fibroblasts, are called mesenchymal cells. So they're there generating their connective tissue proper, and then some baby bone cells begin to differentiate at various places within this fibrous connective tissue model. They become osteoblast-like cells. They begin to secrete the extracellular matrix of bone. These are called ossification centers. If we could see the entire structure of this forming bone, we'd see lots of these little groups of osteoblasts forming and beginning to produce bone tissue. Those osteoblasts continue secreting osteoid, or the extracellular matrix of bone, the ground substance, right, the hydroxyapatite and the collagen fibers. And as they continue to do so, they entrap some of the osteoblasts, such as this one, within the bone tissue, and that now matures and becomes an osteocyte. And that little hollow area is its lacuna in which it will reside. And the osteoblasts continue to produce more bone tissue on the surface, appositional growth. As the bone development process continues, the osteoblasts avoid and work around and kind of build tunnels around the blood vessels in this connective tissue. Now, they omitted the blood vessels from this diagram and from this diagram for the purposes of simplifying the illustration, but it's a little bit weird because there should have been blood vessels there, and in fact this ossification process works by surrounding the blood vessels and avoiding them, and that creates the network of blood vessels is what gives rise essentially to the sort of shape of the spongy bone that's forming here. So as you can see with all these little hollow passageways and then trabecula, we have spongy bone with osteocytes in their lacuna and osteoblasts on the surface building more and more bone. The fibroblasts, I should say mesenchymal cells, begin to multiply and form a denser type of fibrous connective tissue on the surfaces, which gives rise and turn into the periosteum. That's that leather-like jacket we said is on the surface of bones. And ultimately, that periosteum matures, and osteoblasts and osteoclasts remain under the surface of the periosteum. Compact bone plates form right underneath the periosteum on either face. So what we wind up with is a sandwich of compact bone with spongy bone in between, and that is the nature of flat bones. That is the description of the structure of flat bones. In this case, it has arisen by intramembranous ossification. So just take these 4 steps as outlined here, and try to write the description of those 4 sort of steps in your own words, and then you can learn them and you'll be able to tell this story. You could almost draw these pictures from memory, and you can certainly learn to tell the story that's associated with each one of these pictures or steps in your own words, and that's the story I want you to be able to tell. I want to be able to say, explain to me what is meant by intramembranous ossification and what happens during that process from start to finish. So that's your kind of task. So for both endochondral ossification and intramembranous ossification, I want you to work up a description of each of the steps of your own wording, and then learn those things to be able to tell me about it at a later time. Here's a fun X-ray or a CT scan of an embryonic skeleton. And we can see the frontal bones, the cranial bones have started to ossify. Wherever you see the darkish orange color, that's where ossification has begun. And wherever you see the sort of light yellow color, that's just soft tissue, we call it, and it's not ossified yet. It's really interesting because you can see the long bones, they're called, of the appendages. They're the bones of the forearm, the humerus of the upper arm. Those bones have primary ossification centers. Compact bone is forming in the diaphysis of these bones, but there are no epiphyses yet. There's no secondary ossification centers yet. Same thing here. We see the metacarpals and the phalanges. The long bones have begun their primary ossification, but there are no secondary ossification centers yet. Pretty interesting. The ribs have begun to form also by endochondral ossification. We can see some ossification happening in some of the pelvic bones, but a lot of the structures that will be the pelvic bones are still cartilage. So in part 3, we'll go on to talk about bone breaks and bone healing and some diseases of bone tissue. So join me for part 3 next.